Step outside tonight and look up at the sky. On a clear night, the human eye can detect roughly 4,500 stars. That is the entire visible universe from your backyard. Thousands of years of light. Ancient suns, the Milky Way stretched across the horizon. Now imagine that number gets beaten. Not by more stars, by satellites. Because that is exactly what is coming. On January 30th, 2026, SpaceX filed an application with the FCC requesting permission to launch 1 million satellites into Earth orbit. Not 42,000, the number they were already approved for. 1 million. An artificial constellation so vast it would outnumber every visible star in the night sky. There are currently around 10,600 Starlink satellites above your head right now. And that number is already causing problems that scientists are struggling to contain. So what happens when it reaches a million? The answer involves the night sky disappearing, a hole in the ozone layer, a chain reaction that could lock humanity out of space for centuries, and one man having the power to switch the internet off for entire countries at will. This is what 1 million satellites above your head actually does to Earth. To understand where this is going, you first need to understand the scale of what has already happened. In 2019, there were approximately 2,000 active satellites of all kinds orbiting Earth. From every nation, every company, every space agency combined, 2,000 satellites accumulated over 60 years of the space age. SpaceX launched its first 60 Starlink satellites in May 2019. 7 years later, there are over 10,600 Starlink satellites in orbit right now, comprising roughly 2/3 of every active satellite above Earth. More Starlink satellites exist than all other satellites from all other operators in human history combined. SpaceX is launching new batches every 2 to 3 days. Each launch adds dozens more. The number is rising so fast that tracking websites update in real time just to keep up. And Starlink already has FCC approval for 15,000 satellites. That approval came in January 2026. The 1 million satellite application filed just weeks later exists in an entirely different category. A number so large that researchers studying its implications published a paper in the Astronomical Journal just 4 days ago warning that the total number of proposed satellites across all operators has now reached 1.8 million. Not someday. Filed with regulatory agencies right now. 10,000 satellites already changed the night sky. What does a million do? Here is the first consequence and the most immediate one. A study led by Alejandro Borlaf at NASA's Ames Research Center simulated what happens to telescope observations when the number of satellites reaches approximately 500,000. The result was unambiguous. At least one satellite would contaminate essentially every single image taken by every telescope on Earth. Not occasionally, every image, including images from space-based telescopes like Hubble. At 1 million satellites, placed in higher orbits as SpaceX plans for the orbital data center constellation, the situation gets worse. Researchers found that in a perfectly dark sky with 1 million satellites overhead, there would be more artificial points of light than natural stars visible to the naked eye. The night sky as humanity has known it for its entire existence. The same sky that ancient Egyptians used to build their temples, that navigators used to cross oceans, that every civilization in human history looked up at and used to understand their place in the universe, would be permanently altered. Not temporarily, permanently, for every person on Earth, without any of them being asked. The impact on astronomy goes beyond aesthetics. The Vera C. Rubin Observatory in Chile, the telescope that was supposed to provide the early warning system for dangerous asteroids approaching Earth, already has studies projecting that 20% of its midnight images and up to 80% of its early morning and evening images will be contaminated by satellite trails. The observatory that was supposed to protect Earth from asteroid impacts will have its vision partially blinded by the very satellites circling above it. And radio astronomy, which is how we detect pulsars, map the cosmic microwave background, and study the most distant objects in the universe, faces an even more severe threat. Radio signals from 1 million satellites would create interference across virtually the entire radio spectrum that astronomers use. Some of the most important frequencies for scientific observation would become effectively unusable from the ground. Here is the consequence that receives almost no public attention, and according to scientists, may be the most serious long-term threat of all. Every Starlink satellite is designed with a lifespan of approximately 5 years. After 5 years, it deorbits, meaning it falls back toward Earth, entering the atmosphere at high speed and burning up due to friction with the air. This is deliberate. It prevents dead satellites from becoming permanent debris. Right now, between 1 and 2 Starlink satellites are falling back into the atmosphere every single day. That number is expected to rise significantly as the constellation grows and older satellites reach the end of their lives. When a satellite burns up in the upper atmosphere, it does not simply disappear. The aluminum in its structure, and modern Starlink satellites weigh up to 800 kilograms each, vaporizes and converts into aluminum oxide nanoparticles. These particles condense into aerosols that descend into the stratosphere. Aluminum oxide is not an inert substance. It catalyzes chemical reactions that destroy ozone molecules, the same ozone layer that protects every living thing on Earth's surface from the sun's ultraviolet radiation. A study in the Proceedings of the National Academy of Sciences confirmed this through direct air sampling, not modeling. Real measurements of the stratosphere showing aluminum, silicon, copper, lead, and other elements accumulating from satellite reentries. NOAA projects that if 60,000 satellites are in orbit by 2040, a number already filed for by multiple companies, re-entering satellites could inject up to 10,000 metric tons of aluminum oxide into the upper atmosphere annually. One researcher put it bluntly, "We spent decades banning chlorofluorocarbons, CFCs, to repair the ozone hole. It was one of the greatest environmental achievements in history. We are now potentially destroying the ozone layer from above by burning tons of metal through it every single day. And we are doing it without international regulation, without a full scientific assessment, and without the public understanding what is happening above their heads." At 1 million satellites, each with a 5-year lifespan, the quantity of aluminum burning up in the atmosphere annually would be in a completely different order of magnitude. The effect on the ozone layer at that scale is, as researchers admit, genuinely unknown. We are running an uncontrolled planetary-scale experiment in the only atmosphere we have. There is a scenario so catastrophic that space scientists have given it its own name: Kessler syndrome. Here's how it works. Every satellite in low Earth orbit is moving at approximately 28,000 kilometers per hour. At that speed, even a tiny fragment of debris, a bolt, a piece of aluminum no larger than a marble, carries enough kinetic energy to punch straight through another satellite. When two satellites collide, they do not simply stop. They shatter into thousands of fragments. Each fragment is now its own piece of debris traveling at orbital velocity. Each fragment can hit other satellites, which create more fragments, which hit more satellites. The cascade, once started, is self-sustaining. The debris field grows faster than it can be cleared. Every orbit becomes unusable. Every satellite, every GPS system, every weather monitoring instrument, every communications relay destroyed. And because the debris remains in orbit for years or decades, launching anything new becomes impossible. A single collision, in the wrong place at the right density, could seal off access to space for a generation. This is not theoretical. Space traffic management systems are already operating at the limit of their computing capacity, trying to track the current 10,600 satellite constellation. Starlink satellites performed 145,000 automated collision avoidance maneuvers in just the first 6 months of 2025 alone. SpaceX's own constellation is already the #1 source of collision hazard in Earth's orbit, according to space debris experts. At 1 million satellites, packed into the same orbital shells where the current 10,600 operate, the collision probability does not scale linearly. It scales exponentially. The density of objects would be so extreme that automated collision avoidance systems would face an essentially impossible mathematical problem, maneuvering to avoid one object while inevitably moving into the path of another. The same infrastructure that brings internet to remote villages and connects the world could, if something goes wrong at sufficient density, take all of it away permanently. There is a dimension to this story that goes beyond environmental risk and astronomical inconvenience. Starlink currently has over 10 million subscribers across approximately 160 countries. It has been used to maintain communications in active war zones. most notably in Ukraine, where Starlink terminals provided the only reliable communications infrastructure for Ukrainian military forces in the early stages of the conflict. It has provided internet access to remote Amazonian tribes, to cargo ships at sea, to passengers on commercial airlines including Singapore Airlines, American Airlines, and dozens of others. But that dependency creates something that has never existed before in human history. A single private company, owned by a single individual, with the technical ability to switch internet access on or off for entire regions of the planet. This power has already been exercised. Elon Musk personally announced the activation of Starlink in Iran during government internet blackouts. He has publicly discussed restricting Starlink coverage in military conflict zones. In 2022, Musk acknowledged that a request to enable Starlink near Crimea for Ukrainian military operations was denied, a decision that by his own account affected active military planning. A 1 million satellite constellation would extend this dependency to a scale that dwarfs anything currently imaginable. Not just internet access. The orbital data center constellation would also provide the AI computing infrastructure that businesses, governments, and militaries increasingly depend on. The entity controlling that infrastructure would have a form of leverage over global communications and information processing that no government, no international body, and no competitor could easily challenge or replicate. The FCC gave 4 weeks for public comment on the 1 million satellite application. Serious scientific studies of this scale typically take years. Here is the honest picture. Starlink has brought genuine, life-changing benefits to millions of people. Communities that had no internet access now have it. Disaster relief operations use it. Remote medical facilities rely on it. Ships at sea, planes in the air, soldiers in combat, all connected in ways that simply were not possible a decade ago. The technology works, and the human benefit is real. But the trajectory from 10,600 satellites to 1 million is not just a bigger version of the same thing. It is a qualitative transformation of Earth's orbital environment, one that carries risks that the scientific community considers serious and that current international regulatory frameworks are completely unprepared to manage. The night sky changes permanently. The ozone layer absorbs an unknown quantity of aluminum oxide annually from constant reentries. The collision risk approaches thresholds that the world's best orbital mechanics experts find genuinely alarming. And a single private entity gains infrastructure leverage over global communications at a scale that has no historical precedent. None of these outcomes are inevitable. Regulation, international cooperation, technical innovation in satellite design, and responsible deployment schedules could mitigate all of them. The question is whether those mechanisms can move faster than the launch schedule. SpaceX is launching new Starlink satellites every 2 to 3 days right now. The FCC has already approved 15,000. The application for 1 million has been filed and accepted for review. The sky above you tonight still has more stars than satellites. That ratio will not last indefinitely at the current pace. The question is not whether 1 million satellites changes Earth. The research says clearly that it does. The question is whether anyone with the authority to shape that change is moving fast enough to matter.